Hi folks, welcome back. We're going to chat about numbers 21 and 23 in your Unit 2-2 homework. You need to give me a moment here. I've already got the picture for 23, but I've got to get 21 figured out here. Whoops, can't find my cursor. There we go. Whoops. Sorry about this. Here we are. Okay, so number 21. It says a stunt performer swings on a 30.5 meter cable initially inclined at a certain angle here, and then find their speed at the bottom. So I'm going to draw a little picture here, and again, we're talking about 21. The picture on the right is for 23. It says something about somebody, I think they're on a cable, and there's a theta here given in the problem, and they're swinging back and forth like this. So draw a picture of them at the second position here. And we're going to call this position 1 and this position 2. And then write out the work energy theorem, right, which is going to be PE1 plus KE1 plus work equals PE2 plus KE2. And in the first part of this problem, they are assumed to be starting from rest here at position 1. So that'll tell you something about your KE1 term, right? But I'm not going to tell you, right, your homework. Okay, the PE1. If we put a datum like through the lowest point in the problem, what you're going to have to calculate is this height right here for your PE1 term. And if you make yourself a triangle that looks like this, the hypotenuse is whatever the length is given in the problem. And then this distance is adjacent to that. I will give you the clue there how to find that. And then the height you need, which I'll do in green here, in this picture it's this distance, which is from here to here. That's the total length minus this one. So that should be enough to get that height, and you're going to use that here under the PE1 term. The PE2 term, if you define your datum like this, the PE2 term, I will just say they are at the datum. Then the KE2 term will be a 1/2 mv squared term. As far as work terms are concerned, okay, if you draw a free body of the person, there might be a tension this way, but it always makes a right angle to their velocity, right? No work done. The gravitational force is down. And it does do work during this problem, but that's what we take into account with the potential energies. So that should be enough to get you through 21. Let's chat about 22. So I've got the picture for 22 over here on the right. All right, this is the thing right here. I just love this snippet tool. Anyway, they're talking about this system right here, which starts from rest. And if mass 1 is bigger, you can kind of see what's going to happen. This thing's going to start rotating like this. And mass 2 is going to move up to here. Mass 1 is going to move down into here. And I'm sure the V final here is right before it hits the floor. So your 1 and 2 picture, if you will, the system is like this at state 1 and like this at state 2. An important thing to realize is at that second state here, these things are moving now, both of them. And again, you'll notice a little daylight right there, right? This is intended to be an instant before impact. So write out the work energy theorem. I would probably datum it right here. And again, let me put this in, I don't know, like a fuchsia. So your state 1, right, is this. So like PE1 plus KE1 plus work equals, and I'll do this in yellow, this is your state 2. PE2 plus KE2. Wish I would have had technology like this when I was going to school, but anyway. Putting your datum here, this guy will have a potential energy under the PE1. And the problem is asking you to do this just kind of algebraically here, where it says use variables or symbols here. So I would call this just a height. So mass 1 will have a potential energy under the PE1, but mass 2 won't. The KE1, I'm sure it's probably one of these systems starts from rest. That'll tell you something about the KE1. I'll talk about that work term in a minute. PE2, now that's the yellow. This guy has a potential energy, but not this one. That should get you by on the PE2 term. Now the KE2, this thing's moving, so it's got a kinetic energy of 1/2 mv squared, but you know which mass? It's mass 2. So it's going to look like 1/2 m2 v squared, right? This also has a kinetic energy. So you'll have two terms under the KE2. Okay, work term. The reason why it is 0, okay? My picture's pretty muddled up here, but when you draw a free body of this mass, the tension is up. The mg is down, and that's m2g. And as this thing moves in this direction, there is work done by the tension, equal to t times some distance. But when you draw a free body of this mass, and here's the kicker, the tension is up on that thing. The m1g is down. And when this thing moves in this direction, the work done by this is negative, and it's the same work term as this. So long story short, you can treat it, it's kind of like an internal force to the system. It's not an external force that's adding energy or taking energy away from the system. As long as we define both of these at the same time, you don't need to worry about the work term for the tension. So that should be enough to get through A, and then B and C are just putting in numerical values. So I hope you enjoy the video. Have a great day.